All right, welcome back to the course. We're going to wrap up this second unit now with a quick little exam review. As I may have said in the previous exam review, there is quite a bit more detail in the original notes and the original lectures, and this is really just meant to be a broad overview of the various and many things that were covered in that unit. In fact, I'm going to try to keep this as brief as I can and not try to over elaborate on some of these topics since those over elaborated points are already in those previous and in some cases too long videos. So I will try to keep this one short to make up for all those other much longer lectures. All right, so chapters 5 through 8 is where we're at, I think, or five, yeah, that's right, five through 8. So, chapter 5 was cognitive control and working memory. And we start with cognitive control. And in the first part of this, we're talking about uh, controlling our ability to switch from task to task to task as part of the broader topic of divided attention. As we describe divided attention, the idea is that when we are quote unquote multitasking, but again, that's maybe a bit of a misnomer because we aren't literally doing many things at the same time, but rather we are dividing our attention and dividing our resources across many tasks. And we have to switch in a serial fashion, that is, one after another, between these tasks. And so that's what the task switching is here all about. And we talk about there are declines, right? As we add more and more tasks, at some point performance will begin to decline. It's going to become harder to do it. And so our first discussion about where these factors become relevant is about task demand. How difficult are the tasks? But in order to explore that, we need to find a way of defining task difficulty. And this is where we can think of things like cognitive load. So the idea is that the more demanding the task is, the more cognitive or attentional resources it uses. And if we have a finite amount of these resources, then the more tasks we add or the more difficult tasks we add, the more we're depleting these resources. And that's going to impact our functioning here. One way to think about task load is by distinguishing an automatic process from a controlled process, with the idea that the controlled processes are the ones that require this kind of cognitive control and therefore will use more resources compared to an automatic process. Way at the end of these notes, I have a little section on stress and the effect that it has on both attention and working memory performance. And I thought it would be useful to insert it here under task demand because one of the things that we see here is that stress is associated with increased cognitive load and maybe depleting these cognitive resources. So in that case, our ability to engage in divided attention is directly impacted by stress, that is, performance under stress. If you're trying to do something complex but in a stressful environment, then that's where we would expect to see these kinds of impairments to performance. Now, one of the other things we need to talk about with cognitive control here is task interference. So when we are doing any kind of divided attention task, a lot of these studies are what are basically called dual task experiments. So there's really only two things you're doing at the same time. And we can kind of get some insight into the different kinds of interference effects that can happen. So we saw some very basic interference happening in the stop signal task and the Stroop task. The Stroop task in particular is a good example of trying to interfere, or sorry, I should say, trying to inhibit an automatic process of reading by performing the controlled process of color naming. So we see a good example of automatic and controlled processing there too. But we had examples of spatial interference with the Simon task. We had some perception and response interference observed in the flanker task. We've got speed interference in the Fitz task. And we've got response selection interference happening from the PRP. That stands for the psychological refractory period experiments. And so there was a little bit of a convoluted story to tell with those sets of studies and their interpretations, focusing on what we call the central bottleneck theory, that interference happens not at early selection or late selection phases of attention, but rather more at the response execution phase. shifting over to the error business here, that so in these kinds of tasks, these where there's some kind of dual task interference or some other kind of attention switching interference, we may make mistakes, and we have to monitor for mistakes and try to prevent ourselves from making mistakes. And so here's where we talked about the issue of kind of a metacognitive control process happening here, where we have to worry about monitoring for conflicts, resolving attentional conflicts, and then when we make a mistake, we have to detect the mistake and maybe correct that mistake. And then we saw the Rabbit and Rogers experiment, where there is this kind of a old experiment where once we detect a mistake and try to correct for it, this can affect our future reactions and responses, and it causes errors to cluster together in a sequence. And this phenomenon was called error perseveration. So that's kind of wrapping up the cognitive control part. Again, I'm trying to go quickly. So the other half of this set of notes was focused on working memory. We had a look at the original Baddeley and Hitch model of working memory, but we spent more time focusing on the refined model from around the year 2000. So we have here the central executive plus these uh, uh, other memory systems or buffers here, the visual spatial sketchpad, the episodic buffer, and the phonological loop. So simply here, I just have listed that you should, in studying for this exam, make sure that you are kind of basically familiar with the function of each one of those things. What does the central executive do, right? What does the visual spatial sketchpad do? What does the phonological loop do? What are the properties of each one of these components here? In talking about the phonological loop, I'd also describe some research that Baddeley did called the irrelevant speech effect. So review that as well and understanding its relevance to the phonological loop. Also, at the end of these notes, we talked about fatigue and how engaged in, let's say, a divided attention task or even a working memory task over time may cause a decline in performance. So we'll call that cognitive fatigue. And we asked some questions about how can we restore ourselves in these kinds of situations. We know that when you are physically tired, you can physically rest your muscles, but what happens when you are cognitively tired, and what's the good way to rest here? So we looked at different techniques in terms of nature exposure and video games and aerobic exercise as some techniques here, and the different levels of effectiveness for those. Moving into the next chapter, we have two chapters here, 6 and 7, that deal with memory in different ways. And so chapter 6 deals with some of the standard memory stuff here. So here's our kind of classic, bit of an old idea. It's at least 50 years old here, of this sensory memory, short-term memory, long-term memory series of stages of memory encoding here. So make sure you're familiar with that. That's the Atkinson and Schifrin idea from the 1960s. Then from there, we have some research on sensory memory, different kinds of sensory memory. So the visual, iconic, and auditory echoic versions of that. And George Sperling's research on how he used both the whole report and partial report techniques to show that sensory memory has a large capacity but a very, very short duration. For short-term memory, we could also ask questions about capacity and duration. Under capacity, this is where we get the magic number 7 idea. The duration effect, we can look at the Peterson and Peterson study, where they found that if you were engaged in a secondary task, that the memory trace fades away pretty much after 12 seconds. But that would not align well with the magic number 7 that suggests that forgetting in short-term memory really originates because of what we'll call the displacement effect. And this is where the probe digit procedure, where they manipulated the slow versus fast rate of presentation to disentangle the decay effect from the displacement effect. And their findings shows that forgetting was largely attributable to the displacement magic number 7 type phenomenon. But we also mentioned that there's even an interference effect that can cause forgetting from short-term memory. And we see this maybe with the serial position effect and the primacy and recency effects that are part of that. Under long-term memory, we talked about the encoding processes and how can we encode new long-term memories. So there's just rehearsal, repeating things. We talked about mass practice and distributed practice and what works there. Chunking, elaboration, the role of schemas and knowledge and top-down information are all relevant here. And also, at some point in these notes, we have addressed some of the underlying physiology here and looked at the role of the hippocampus in embedding and encoding new long-term memories. For retrieval, we looked at the context dependence here. There was a lot of detail there in terms of place dependence and mood dependence and things like that. So go back to the original notes there. Um, we asked questions about decay of long-term memory, although that was something that was discussed where we're kind of not entirely clear to what degree long-term memories really decay. And that better way to think about challenges with retrieval are to think about interference and maybe even inhibition of certain long-term memories. And we also then looked at some distortions of memory. So false memories, remembering things that didn't happen, or simply just misremembering certain events. And so we looked at the Dease lists and the research of Elizabeth Loftus there. And we wrapped that up by talking about misremembering as a kind of a metacognitive failure. And we had a little extra detail in there about some of the different kinds of metacognitive processes. So certainly study that too. Next up, we have the next chapter was on memory systems. So this is chapter 7, I think. So different kinds of memory systems. We've mostly talked about the difference between explicit and implicit memory, what kinds of subtypes there are. So under explicit memory, we see here we have the declarative, episodic, semantic. We also talked about amnesia here, right? So one example was the patient HM who had his hippocampus removed and therefore ended up with permanent anterograde amnesia. But what we see is that this primarily affected explicit memory systems. And his implicit abilities, such as ability to learn new skills, like in the mirror drawing task, was not particularly impacted. So that fits into the subtypes of implicit memory here, like perceptual skills and perceptual learning. We also talked about imagery and perceptual and spatial memory, semantic networks, and the spreading activation model is another way of representing how memory is organized and how knowledge is organized and stored. And also Eleanor Roche's research on hierarchical knowledge representations as yet another way of talking about how knowledge can be organized. And so that was the research on superordinate, basic, and subordinate levels. So that dealt with, for example, looking at a picture of a dog. Calling it a dog is when we are operating at the basic level. If I were to call it a mammal or a animal, there I'm working at the superordinate level. But if I was to identify, just look at it and say that's a German Shepherd, then I've switched to working at the subordinate level. And what Roche found is that most people operate at the basic level most of the time, except when we might happen to have some level of expertise on a given subject, in which case that might cause us to switch to work more at the subordinate level. All right, wrapping up this review, the fourth and final chapter of this unit was all about language, and this one I know went on for quite a while. So we started by talking about how to define language. So I have the 4 key components of that right here. Language must be semantic, that is, it has symbols that have meaning. It must be generative. We must be able to say new things. It must be communicative in the sense that we're able to transfer ideas to other people. And it must have rules, and that's the grammatical side of things. And then we kind of expanded a little bit on some of the grammatical rules, like the phonological system, the morphological system, and the syntactic system. And the whole idea of a transformational grammar about how these rules are implicit forms of knowledge that convert ideas into the sounds, and then we use that to communicate to others. On the topic of communication, we can also bring up the issue of the pragmatics, the utility or usefulness of language. And this is where when we are communicating with others, we make certain presuppositions about what other people know, and this frames the way in which we speak to them, so that we allow them to draw certain inferences from the way we say things. And so this whole idea of theory of mind, our ability to even understand the knowledge other people have versus the knowledge maybe they don't have, and how that kind of goes into things like asking people questions, as well as these presuppositions and inferences, then that's all part of that pragmatic business here. From there, we had a little section on speech production. We talked about Brokaw's area and some of the other brain regions involved in that. We talked about how speech is produced in terms of this articulation. So talking about place of production, like using the lips or the tongue against the alveolar ridge and things of this nature, and stops and fricatives, and having voiced and voiceless consonants. And this is where we also began to talk about the phonemes a little bit, right? The phonemes being the so-called smallest meaningful unit of language, and therefore the building blocks of language. This becomes a bigger challenge when we shift over to speech perception, because here the idea is that if the phonemes really are the building blocks of language that go into our production, what happens when we produce the phonemes is that we co-articulate them, and they blend and blur together. And so this presents a particular challenge for understanding speech perception from the perspective of the listener, whose auditory system has to take in this complex speech sound of a bunch of phonemes that are all blended together, and somehow break that back down and decode that down into the constituent isolated phonemes. This is where we've talked about Hackett's Easter egg analogy and the challenge associated with identifying phonemes in the signal. So we looked at the speech signal in terms of waveforms and spectrograms, and we find it is a particular challenge to find the identify phonemes in those signals here. Although the spectrogram research did show a little bit of promise. So we talked about the categorical perception experiment, where they manipulated the formats using synthetic speech segments, and were able to generate some perceptual response there. We also could suggest that maybe an alternative is to move away from phonemes and focus more on the auditory or the speech gestures, and that's where we talked about the McGurk effect a little bit, showing how visual perception also influences what we hear when it comes to language. Wrapping up, a big chunk of this chapter was on word recognition models. So there was a long list of them. I have that down at the bottom. The first thing is that make sure you're familiar with the general ways of categorizing these models. So some are bottom up and some are top down, but we sometimes see that bottom up modules are sometimes called modular, and the top down models are sometimes called interactive. Some of them can be described as selective, meaning that when they activate a word, they're only activating one particular word meaning at a time. The ones that are labeled as promiscuous activate multiple word meanings all at once, and then pare down the possibilities from there. And so there's some differences there in how some of these models work here. So down at the bottom, rather than going into all of that same level of detail about each and every one of these models, I simply just listed them here. And so what I'm just noting here is that your goal is to identify each one of these models in terms of how it fits as being either bottom up or top down, selective or promiscuous. And also, if you're able to just give a general base description of how each model works and some of the phenomenon it can explain. We talked about things like the phonemic restoration effect. And so some of these models might fail and others might do better. Or we also talked about the garden path effect and how some of these models would account for some of that stuff. Or word frequency effects. Again, that's another common phenomenon. So I won't read the list to you here, but you can see that. So go through the original notes for more detail. One last thing was the little comment on language, the relationship between language and thought. This relates a little bit to the broader discourse concept. But where Sapir and Worf are coming into this here was their view that we now call linguistic determinism, which would suggest that the language and the structure of the languages that we learn in childhood strictly determine the way we are able to even think about the world and think about reality. Most linguists do not accept that, but there is a softer view known as linguistic relativity, which instead claims that the language doesn't necessarily determine how we think about reality, but can certainly influence the way we think about reality and changes the way we think about things. But even does not have 100% a universal acceptance, right? Many psycholinguists believe that thinking and the way we think about reality is much more a function of perception as opposed to the nature of the language that we learn. And that maybe perception determines and cognition determines language rather than language determining cognition, right? All right. Well, We have successfully done this in, I hope, a reasonable amount of time. So as always, if you have questions about any of this material heading into this exam, come to my office hours, send a message on the Canvas inbox. And other than that, good luck.